Hey there, welcome back to School of Tomorrow. If you've been following this curriculum some, you'll not be surprised that I'm going to talk a little bit about Codesters, and then I'm going to switch to Spider here, which is an IDE for developing Python programs. And I'm going to show you some recent activity on the Python Mailman, which is Python EduSig, which is an archive where I publish a lot, and my most recent email has been, "Hey, how come I'm getting bold facing instead of a double star? Because in Python, as you know, the way we show exponentiation, like raising 2 to the 607th power and then subtracting 1, that turns out to be a prime number of all those digits, right? That's called the Mersenne prime number 14. The one before that, you raise 2 to the 521st power. Huge number. It's going to be an even number, though, because it's all 2 times 2 times 2, 521 times. Then subtract 1, and what do you know? You get a prime number. But not every 2 to a power minus 1, not even every 2 to a prime number minus 1, is going to give you a prime. It's just a lot of them do. And those are called Mersenne primes. So I'm just cutting and pasting really the output, the printed output from this program, which borrows from an older Python 2.7 or 2.x archive at the Oregon Curriculum Network in support of my cryptography sections, right? Because we learn RSA by high school, right? Kind of like at Phillips Andover. So what I notice when I cut and paste that stuff into the EduSig listserv and send it off by mail reflector to subscribers is that the archived version takes that double star and turns it into some kind of formatting instruction, kind of like a markdown or something. So I'm wondering about how can we fix that, because also the Python code's not showing up indented and so on. We only recently moved from Mailman 2 or whatever that was before to this Mailman 3. And so I'm getting used to maybe there's some settings that we can use. I am a list owner, but believe it or not, all I asked is, are we going to lose anything archive wise? And I said no. And the original posts are there by attachment, but I'd like to just be able to see them, not have to download anytime I want to see the original. Anyway, that's kind of stuff going on behind the scenes. Here we are at the GitHub repo for School of Tomorrow, where the code for what I just showed you in Spider actually is. There's primality testing as we march through the candidate Mersenne primes. I call them candidate. Here they are. I just go up through 650 trying every one, and it really quickly finds that most of them are not prime, and it filters them out at first by just sort of brute force primality testing using the isPrime function from earlier days, where I actually generate primes consecutively from 2 forward, 2, 3, 5, sort of keeping a list in underlined primes. And then I abandon that approach after the primes, or candidates, I should say, get to be a certain size. After a certain number of digits, I switch over and start using a different primality test. So that's what I'm asking for here. Are we under 10 digits? Okay, just brute force check. And if we're over 10 digits, let's switch over to this Miller-Rabin thing, where you can find in Knuth's Art of Computer Programming Volume 2, page 395, what I'm testing for, but also check YouTube's Miller-Rabin. That's the same Rabin as in RSA, and remember, RSA is our goal. Now, this is high school level, right? Going back to middle school, this is coming up tomorrow and Wednesday. The level at which middle schoolers are at is they'll benefit from studying exhibits such as this one. So let me just run this for you, give you a sense of School of Tomorrow content. We are studying collision detection. Now, Python out of the box is not going to give you this. This is a dialect or enhanced Python that compiles to JavaScript in your browser. You can set up an account for free, and what it does is it launches sprites into sort of a tank But then if every so often, right, I've got control of the interval, regularity with which pairs of sprites are created. And they're created in this case from opposite edges, right? And they sort of bounce around by default. But when they touch each other, that enacts their collision detection capabilities. And this is something, like I say, you're not going to get all this from just ordinary Python. But these sprites, they can tell when they've been touched by another sprite. And when that happens, that sets off kind of a resolver, something to figure out, okay, now that two sprites have touched, let's get what those sprites are. And these come in not as specific individuals. In other words, I'm not saying these arguments belong, these can be any two sprites that happen to collide. So think of a busy city and the different kind of fender benders and so on you might have in a city during the day. You've got pairs of vehicles, to keep it simple, let's say pairs of vehicles coming through the door here to figure out what to do now that they've touched each other. And it's up to you, the coder, to specify that. And in this case, I get the names of the two sprites involved. It's kind of think of a police officer coming to the scene and getting the names. And then I remove the sprites. You could think of moving the cars to the side of the road. But actually, in this case, just delete them from the canvas. I haven't had to keep track of them or anything in a list because they each have their own sort of ID, and I can remove them once I figure out, you know, who they are, and that comes to me for free through the front door, you could say. I can specify, okay, now that I've got your names, I can remove you, but I will log in the background who hits who. Fish hits UFO, fish hits fish, all these combinations of piranha and UFO hitting each other. I can easily change those two sprites. Here's where I make a pair of them. They come in, as I said, at intervals from the opposite sides. I can play around with the settings and so on. So this is what we would call middle school Python. And then this other stuff with the high precision integers and the extended arbitrary precision, I should say, not floating points, but big arbitrary precision decimals. In the case of Python, it comes with the decimal library, and you can also get Gimpy2, which is in many ways more capable and faster. But right there in the native standard library, you do have the decimal type, and it is very capable. And as you've seen in recent videos, this is our bridge into a sort of curious geometry embedded in American literature that this school specializes in sharing. So I want to take these geometric shapes and assemble them. I'll end with some show and tells here. This is an old book from the New Math era. Back when I went to school, I got the New Math, right? That's what it was called. And there was some paranoia about Russia. I know, nothing ever changes, right? And this was kind of marketed as we need to get up to date and send people to the moon and stuff. So there's more number theory and group theory in here. Really, group theory is what's in here. Group, ring, fields, just applied to ordinary number types, as we call them, right? Natural numbers, rational numbers. Actually, we'll do natural, then integer, then rational, right? Each one contains the one before, and then real, and then complex, okay? So it marches us through the evolution of the numbers to these bigger and bigger sets, and then talks about their group theoretic properties and so on. It's a pretty good book. And again, this is what I today would call lambda calculus, knowing full well that that has its own meaning, right? From Alonzo Church, Princeton University of Advanced Studies, kind of bevy of thinkers there. But it's pretty obscure, and we could afford to magnify the meaning of lambda calculus to just rebrand computer science in a way that brings it into the stable of mathematics so that we can still market it as mathematics if we want to. Instead of saying we have to hire computer science teachers at high schools, we can hire math teachers who know lambda calculus. But does that include any 3D geometry? And again, I'm almost without competition in terms of using this particular geometry. In terms of very specific School of Tomorrow content, that takes you directly into this geometry, I'd say there is no competition. So Oregon Curriculum Network is in a pretty good place in terms, but then it's not a good place in the sense of I don't want it to be that way. I'd prefer to have competition and know this material was getting out there, this American heritage, rather than have the thing all to myself. It's like I feel like a dragon on the pile of gold. When am I going to spend it, and where do I get to go? Just flying around and blowing fire is not fun. So you want a tourist industry. You want. I would prefer to have more colluders. Okay, and that's been a theme here on this channel. So check my other videos if you're interested in this kind of content. Again, fighting Quakers, go Quakers. A couple more things. If you happen to pick up any Mad Libs like I did for free here at our Quaker Meeting House, use this if you like to help teach about string substitution, just the idea of Mad Libs. I do that a lot. Going back, you'll see how I use that to generate the POV array scene description language I need from my vectors, right? So I have these Python vectors, XYZ, quad rays, if you know what those are, also, and I play games of creating polyhedrons. And data visualization, as wonderful as that is not set up to just create your arbitrary polyhedron. Those aren't considered data visualizations. So if you want like an icosahedron on the screen, good luck finding a package to help you. You'll find it though in Visual Python, and a lot of my work over the years was using Visual Python. I'll take you to Oregon Curriculum Network. Here's cryptography stuff coming up. This is closer to what we've been just looking at right now. Group theory, the public key cryptography, all kinds of stuff on cryptography here, right? Enigma machine, all this kind of stuff. So this is what I was doing. When did I date this page? Back in very early. So this is like 20 years old, right? 20 years ago, I was doing all this, and so now I just kind of bank on it as part of our School of Tomorrow's content, putting theory into practice. And since that time, things like Codesters have popped up that make the work really quite a bit easier. And let me also show some of these free resources like, yes, kids can learn Python. This is a free Kindle edition. And so I'm just hearing about it and I'm saying, yeah, I want to share links more because I think we spend too much time just relying on search engines and they cough up like 10 links and we always pick one and it's like you're never going to find most of the jewels if the way you dig is you take a little plastic spoon and go out and just piddle in the dirt a little bit and expect to find gold, right? It's not going to work. So a search engine, if you just stay at that level, can be very superficial, and you also want to curate links and help others find stuff because without curation, you don't have any filtering. Curation equals filtering, and without filtering, you just have a tsunami of irrelevance, right? And you lose track of what's worth anything. So in that spirit, I often teach Python as a means to creating your own bookmark files. Just as a first application, here's something you can do. Start curating your bookmarks. Use CSV, use JSON as file format storage, or even better, use SQLite, which is built right in. So already we're starting to build a database, learning how to use SQL, structured query language, very useful. Finally, shout out to Bhutan. This is an old family home. We're a Swiss family, Urner, U-R-N-E-R, and ancient ties to, well, I don't know how ancient, but Bhutan you'll find has pretty interesting culture with a Swiss bakery when I was there, and most people remember from the 80s and so on, right in the middle of Thimphu. I was there in the 80s. My parents lived right up on the hill there behind Thimphu for many years. Dad worked at the Ministry of Education, as an employee, and Helvetas was one of his paying his salary. He started there with the World Bank, but switched to Helvetas so that it was not loan money that he was paid. It changes your relationship to your coworkers if they think all the money you're making is something they have to pay back versus you're paid for a gift of the Swiss or whatever, right? So he had a good time there. I had a good time there. I just went and stayed for months at a time, as long as I could, right? All right, we'll talk to you soon, and hang in there.